All the source code and the files I use are going to be on my Patreon. Link in description. $5 and you can get access to all my source code from all my videos and all the files that I use. What is going on, guys? In this video I'm going to show you how to make an injector that uses thread hijacking. So it hijacks one of the target program's threads and gets it to load our desired DLL. So the first thing that our injector is going to do is it's actually going to get a handle to the process, and once we get that handle we can loop through all the threads that are running in that process, and we're going to look for a thread that's owned by the actual process, not like a remote thread that's owned by another process, which that's a technique that we used in the last injector tutorial using load library, where we used create remote thread. That's the difference between these two. In that one we're creating a remote thread, but in this one we're actually going to hijack the target program's main thread, and we're going to get it to execute our own code. So once we find our target thread, the one that we want to hijack, we're going to allocate memory inside of the process, and in that memory we're going to store the shellcode and the path to the DLL that we want to inject. So we're going to allocate some memory in the program, and we're going to store our shellcode, which is just a bunch of, it's a character array of bytes. After we do that, we're going to suspend the thread that we want to hijack, and then after we suspend it we're going to allocate memory inside of our own process. So we're going to allocate our own memory, and this is where we're going to copy the shellcode in here, and we're pretty much just going to get it ready to copy and paste it into the target program. Okay, so we're getting the shellcode ready in our injector, and then we're going to add the DLL path at the end, and then once it's all ready we're going to use write process memory, and we're going to write it to the memory that we allocated into the target program. And once that's done, we're going to get the target thread to execute our shellcode. So we're going to change this pointer, and we're going to make it point to our shellcode here so that it executes our shellcode. And inside our shellcode, we, at the end, after we've loaded the DLL, we return and we let the thread continue to execute its own code so that the program doesn't crash. It's similar to function detouring, where at the end of the hook you want to return normal program flow and the regular code. So that's pretty much how it works. We get a handle to the process, allocate memory, allocate our own memory, we get the shellcode ready, and then we copy the shellcode into the target program, and we get the target thread to execute our shellcode, and that's what loads our DLL using load library, and then it returns the thread to its normal code execution. So let's start coding it. It's going to be a console application. I'm just going to call it thread hijacking. I didn't even spell hijacking correctly, but whatever. Alright, so you want to make sure that your program's set to x86 here, because this is only going to work for x86 programs. Like I said, it is possible for x64, but you need to use different shellcode. Yeah, so now to get this working, you need to add some macros into your project settings. So you want to go into the project settings, and you want to click C, C++, and then preprocessor, and you want to go into the definitions here, click edit, and in here you want to add two macros. I'll just get them real quick. So these are the two macros you want to get in there. I'll probably put them in the description so you can just copy and paste them. If not, then just copy it off here. Those are the two you want to put in here. So just like that on a new line, and yes, that's all you have to do. Just click OK, and then you want to apply it, and then everything should work. Let's start with the includes. So I'm going to get rid of that, and we're going to include windows.h. We're going to need tl help 32. We're going to need string, and lastly we're just going to use stdio. and then we want to say using namespace std. Okay, so we're gonna have to include a library here. Now it's going to be ntdll.lib. So you want to say hashtag pragma comment and then lib, and this is how you include libraries in your C++ code, and just put ntdll ntdll.lib. Okay. Yeah, so this is okay, and the reason we're including that library is so we can use this function called RTL adjust privilege, which is going to let us adjust our program's privilege so we can debug the target program. So we need to include this function that we're going to use. So we say extern c nt status, nt API, and it's called RTL adjust privilege. I think that's how you spell it. Yes. And it's got a couple parameters. So the first one's a ulong, and that's the privilege code. And then it's got a boolean, and that's called enable. And then another one, current thread. And the last one is a pointer to a boolean, and that one's called enabled, which is the previous state of the privilege. So we need to put a semicolon at the end there, and then we're going to define a value here, and this is going to be called se debug privilege, and this is the privilege that we want to have on our program. So we want to have the debug privilege. So when we're calling this, we're going to put se debug privilege in here. You can just put 20, but I like to define it so it's easier to read the code. And that's going to let us get debug privilege so that we can access the threads on the target process. So after the define there, we're going to create our shellcode. So it's going to be a char array, and I'm just going to call it shellcode, and I'm just going to paste it because I'm not going to write it out. So this is the shellcode. So I'll put a picture up of the assembly that it translates to. Okay, so this is the assembly that it translates to, and I'll just run through it quickly. So what we're doing at the start is we're doing push AD, and that's going to push all of the contents of the general purpose registers onto the stack so that we can access them. And then we call start. So in start, the first thing we do is we pop EBX off the stack, and then we subtract start from EBX, and then we move 0x CCC whatever. That's just a placeholder basically. During runtime, we're going to change that value to the address of the function load library. So you can think of that as the address of load library. So we're moving the address of load library into EAX, and then we're going to load the effective address of data plus EBX, and what that is that's going to be the DLL path, right? So you see data down at the bottom, that's going to be where the DLL path is going to be stored. So basically we're loading the address where that's stored, and then we're storing it in EDX, and then we push EDX onto the stack. So we're getting it ready for the function call of load library. So since the DLL path is a parameter for the load library function, we have to push it, and then we can call load library, which is stored in EAX. So once we call load library with the parameter there of the DLL path, then we can pop everything off the stack, and then we push another 0x CCC whatever, that's like another placeholder, and that one's going to be the EIP, or the instruction pointer for the thread. Basically what the instruction pointer is it's a pointer to the next instruction to be executed, right, in that thread. So we're going to make that point to the thread's original code, so that once we've finished injecting and calling load library, we point it back to execute its own code, so that we don't crash the program, and then we return at the end of the shellcode there. So that's pretty much what this shellcode translates to. Okay, so I'm going to use these functions which I made in the last video. If you haven't seen it, it's going to be in the top right of your screen there on the card. Go watch that, because I'm not going to explain these functions again. And also in that video I explained load library and that injection technique. So if you don't understand what load library is or how that technique works, go watch that one and then watch this video. So I'm getting errors here, and that's because I need to change this one project setting. So you want to go into general, and down here where it says character set, you want to make it multi-byte, and the error should go away. Okay, so we got these functions here, and then now we can start coding in main. So I'm going to write all the variables first, and I'll explain some of them, and then I'll start coding the actual injector. So the first thing we're going to need is a pointer, and that's going to be called pointer. Next thing, we're going to need a couple handles here. So we're going to need a handle to the process, a handle to the target thread, and we're going to need a handle for the snapshot of all the threads. So when we loop through the threads, we need a handle for the snapshot. And then we need a couple void pointers here, so I'm going to use pvoid. And we need one for the memory that we're going to allocate, and our own allocated memory. Okay, so this one's going to be for the target program, the memory allocated in the target program, and this one's going to be the memory allocated in our own program. So we're just calling that a buffer because we're going to use it as a buffer. So after that, we need a process ID. And then we need this just to call this adjust privilege function. We don't actually care about this variable, we just need it to call the function. So next we're going to need thread entry 32. This is going to store data about the threads when we're looping through them. And the next one is going to be context, and this is going to store the thread context. So we can change the instruction pointer of the thread. Next we're going to need a character array for the DLL path, and I explained this in the last video. The reason it's max path is because that's the maximum size of a directory. Go watch the load library video which I linked before if you don't get that. Next we're going to need a constant char pointer. That's going to be the DLL name, and I'm just going to hard code these. You could have it passed as like a console argument, but I'm too lazy, so I'm just going to hard code them. So this one's, I'm just going to call it test DLL YT. That's the DLL I'm going to use. I coded that DLL in the last video. All it does is it just shows a message box once it's injected. If you want to know how I make it, just go watch the last video. We're going to need another one. This one's going to store the window title, and this is how we're going to get the process ID. So I'm going to use Counter-Strike as an example. So you want to put the title of the window. So Counter-Strike's title is Counter-Strike Global Offensive, just like that. And then so now we need to initialize these two variables up here. So for TE32, so we just need to set the size of this to size of TE32, and that's going to let us populate the structure. And we need to do a similar thing for the context. So we need to set context flags to context underscore full. And what this flag means here is when we get the thread context, we're going to get the full thread context. Now we can adjust our program's privilege. So we're going to use RTL adjust privilege, which we defined up here, and this is stored in NTDLL. And we're going to pass SE debug privilege, and then we're going to say true, and then false, and this is where we pass the buffer boolean here, which we don't care about, we just need it to call the function. So what this is doing is we're passing SE debug privilege, which is the number 20, and that means we want to give our program debug privilege so we can debug other processes, right? So we're escalating our privilege here. And the second parameter here basically just means, do you want to enable this privilege or disable the privilege, and we want to enable it, so we're passing true. And the third one is, do you want to enable it just for this current thread or for the whole process? And when you pass false, that means for the whole process. If you pass true, it'll enable it just for this current thread. And then this is just a buffer boolean, and this stores the previous value for this privilege, which we don't care about. So we're just going to pass that variable, and we're never going to use it again. Okay, so now we're going to use a bit of code from the last video. I'm just going to copy paste it because I can't be fucked. So all it's doing is just checking if the DLL file exists, and then it gets the directory of that DLL file. After that, we're going to want to get the process ID, and we're going to pass the window title, and the process ID, we're going to pass it by reference. Actually, we don't have to. It's already going to pass it by reference. Okay, and then we're going to check if it works. I'm going to copy paste this again. Yeah, so what we're doing is we're checking if the process ID function worked. If it didn't, we throw an error, and then we're going to open a handle to the process, and we check if that worked as well. I have explained all of this code in the previous video, so if you want an in-depth explanation on all this code here, go watch the last video. After this, we're going to take a snapshot of all the threads in the target program, and then we're going to loop through them. So we're going to initialize our snapshot value here by calling create tool help 32 snapshot, and we're going to pass the flag th32cs underscore snap threads. Okay, and then we're going to pass null. So what this is doing is it's going to take a snapshot of all the threads that are running, and then we're going to loop through these threads, and we're going to check if we're going to look for the one that's running in our target program. So we're going to just call thread32 first here, and we're going to pass hsnap and then te32. And now we're going to loop through them all. So we're going to do a while loop. I'm going to say while thread 32 next, which basically means while there's a next thread in this snapshot. And we're going to pass the parameters here. Okay. So we're giving it the snapshot, and then it's going to store the information of the thread in te32. So we're going to check. We're just going to do one if check here, and we're going to check if the thread's owner process. So we go here, owner process ID. We're going to check if that equals the proc ID, which we've got up here for the target program. So if this thread is owned by the target program, we've found our target thread, and we're just going to break the loop. Okay. Since we found the target thread, we can close the handle to the snapshot since we don't need it anymore. And then now we can allocate memory into that process. So we're going to call this function here, and that's going to be into the target process. I'm going to pass null. We want to make the size 4,000 kilobytes, which is basically a page of memory. And then we want to commit the memory and reserve the memory as well. If you want me to explain these flags and stuff, I explained it in the last video. And then we want to have read-write permissions. Okay, cool. Then we're going to check if that worked. I'm just going to copy paste this code. Now we're going to check if it if that worked or if it failed. So if that allocated memory isn't pointing to anything, it failed. So we're going to close the handle to the process, and we're going to throw an error saying this failed. Okay. So if it worked, we're going to open our target thread. So we're going to use hthread here, and we're going to use open thread. This is going to open a handle to the target thread that we want to hijack. So we want to have all access to the thread, and we're going to pass false here, and then we're going to say the thread ID, which is this one. Okay, and I spelt this wrong. Okay, so we're going to check if we actually got the handle or not. So if it's not a valid handle, we're going to throw an error. So we want to free the memory first. So I spelled that wrong, but it's whatever. So we're going to free the memory here. And then we're going to close the handle to the process, and we're going to throw an error, and we're going to say that this function failed. Okay. Alright, so after all that, we can then suspend the thread. And what this does is it suspends the thread. So basically it stops it from executing its code. It just pauses it. And this is going to let us get the thread context. So you can't get the thread context unless you suspend the thread. Otherwise it won't give you valid values. So we're going to pass the handle to the thread, and we're going to store it in our context variable here. Okay. So we've got the thread context. Now we're going to allocate a buffer in our own program, and we're going to get the shellcode ready. So we're going to use virtual allocation, and we're going to pass null because we want it to be in our own program, and we're going to store a hefty amount of memory here, make sure we can fit everything, and then we want to commit the memory, and we want to reserve as well, and we want to have read write. Okay, and then we're gonna set our pointer here. We're going to set it to buffer, and we're going to make it typecast it to a byte pointer here, and then now we can copy memory here, and we're going to copy the shellcode into our buffer. So that's how we do it, and we're going to say size of the shellcode. Okay. So what this is doing is it's just copying the shellcode into our buffer here, into the memory. And since we've stored the pointer to the memory, we can loop through and look for the placeholder values. Remember in the assembly, the 0xccc, we're going to loop through and we're going to look for these, and we're going to change them to the proper address values. So we're going to change the first one to the address of load library, and then we're going to change the second one to the current instruction pointer so that we can restore it after we inject. So we're going to do a while loop. And we're going to dereference the pointer, and we're going to see if it's equal to 0xb8, and if the next byte is, so we're going to check the next byte, and if that's 0x cc, let's check how many there are. 1, 2, 3, 4. So 8 C's in total. 1, 2, 3, 4, 5, 6, 7, 8. So if it equals that, then we know that this is the first placeholder which we have to change. So if you look at the shellcode up here, we're checking for the byte 0xb8. So you scan through and you find it here, and then we go +1 and we check if it equals 0xccc, the placeholder. Okay, and if we find that, so if we found that, then we're going to change it to the address of load library. So we're going to say this here. We're going to say that we want to make it equal to the address of load library A. Okay, and there's another placeholder which we need to do. So the next one, I'm just going to copy this, and the next one is going to be for 0x68. Okay, and we want to make sure the next one's 0xccc. So if we look at the shellcode here, we're looking for 0xc8, so that's here, and then we're going to check, and then we're going to check the next byte and see if those equal 0xccc, whatever. So if we do find it, we want to change this to the current instruction pointer. Okay, and so since we're storing the instruction pointer, we can restore it at the end of the shellcode. Okay, and we're going to do one last thing here. If it equals 0xc3, which is the return instruction, we're going to increment the pointer here to go to the next byte, and then we're going to break the loop since we've set all the placeholders. Okay, and in the loop here, we want to make sure we're incrementing the pointer value each time. Okay, so basically what we're doing here is we're looping through the memory that we allocated byte by byte by incrementing the pointer value by 1 each time. And if the value is 0xb8 and the next one is this placeholder value, then we set the first one to load library A, and then if we find the next one, which is at 0xc68, we store the original instruction pointer value. And then once we reach the end, which is the 0xc3, so if you go up here, the last one is 0xc3, and then we go to the next byte after that, so where pointer is now going to be 1 byte after the shellcode, and that's where we're going to store the DLL path. And then we break out of the loop. So like I was just talking about, where pointer is at the next byte after the shellcode, and that's where we want to store the DLL path. So we're going to use strcopy. It's going to let us copy a string into the memory. So we're going to typecast to a char pointer because that's what we're writing here, and we're going to be writing the DLL path into the memory. So what this is doing is this is all the shellcode here, and then at the end of the shellcode we're putting the DLL path after the shellcode. Okay, so this is all in our own program, in our buffer, our allocated memory. And so we've got all this shellcode and the DLL path ready. Now we can copy it over to the target program. So the way we're going to do that is we're going to use write process memory. So we want to do an if check and make sure it works. So we're just going to say write process memory, and we're going to pass the handle that we have to the process, We want to do it at the allocated memory here. We want to write what's in our buffer, and what's in our buffer, the shellcode and the DLL path. So that's what we're writing, and it's going to be the size of our shellcode plus the length of our DLL path. So that's going to be stored at pointer, right? So the shellcode plus the length of the DLL path, and then we're just going to do null pointer for the last argument because we don't care about that. And this is an if check, so if this doesn't work, we're going to free the memory. So first thing, we want to free the memory in the target program. So that's going to be in H process. It's going to be the allocated memory. And we're going to say null, and then we're going to release the memory. And then we want to resume the thread, the target thread. Then we can close the handle to that thread. We can close the handle to the process. And then we want to free the memory that we allocated in our own program. So that's going to be buffer. We're going to say null, and then we want to release the memory. Okay, and then we can throw an error and we can say what happened. This function failed. And we're going to say failed to write process memory. Okay, cool. So at this point, we've written the shellcode and the DLL path into the target program. Now we need to tell the thread to execute our shellcode. So we're going to do that by changing the EIP register, and this is just an instruction pointer. I explained this before. This is a pointer that points to the next instruction to be executed. So since right now the thread's going to be suspended, so it's not executing anything, we've copied our shellcode into the target program. We have a pointer to that shellcode. What we're going to do is we're going to set the thread's instruction pointer to point to our shellcode. And then once we've set that pointer, we're going to resume the thread, and it's going to execute our shellcode. And within our shellcode, we've stored the original instruction pointer, and that's in the shellcode. We restore the instruction pointer, and that's going to let the thread continue its own code, continue executing its own thread. And that's going to let the thread continue to execute its own code without crashing the program or anything like that. So we're going to make this point to, we're going to typecast it to a D word, and it's going to be allocated memory because that's where the shellcode and stuff is. Now we're going to set thread context. So we're going to check if it doesn't work. Set thread context. What this is going to do, this is where we set the new context. So we've changed the instruction pointer, and we're going to update that basically in the thread. So we're going to set the thread context in our target thread here, and we're going to put CTX. Okay, and if that doesn't work, then we're going to have to pretty much do this. And then we just change the error message here. We're going to say set thread context failed. Oops. Put that in here. And we're going to say failed to set thread context. Okay, so we free the allocated memory, we resume the thread, close the handles, and then we free the memory in our own program, and we throw the error and exit the program. Okay, so if that all works, we're going to resume the thread of hthread, and with the new instruction pointer, which we set, it's going to execute our shellcode, and then our shellcode is going to return to the regular code execution of the thread. So after all that, we can close all our handles, So we're going to close the one to the thread, and then we want to close the one to the process. Oops. And then we're going to free our memory. So we're going to free the memory to our own code. And then we're just going to have a message box that tells us it's successfully injected. So we're going to say null here. And then okay. And then we're just going to return null, and that's going to exit the program. So that should be it. That should be the thread hijacking injector. We got all our variables here. We set our program's privilege to debug privilege, so we can essentially debug the target program. We check if the DLL exists. We get the directory of the DLL. After that, we get the process ID. Then we get a handle to that process. We take a snapshot of all the threads. We find our target thread, which is just a thread that's owned by the target process. Once we find that, we allocate memory in that process, a page of memory. And then we open the thread, get a handle to it. We suspend it so that it pauses it, and then we can get the thread context and store it in CTX here. And then we allocate our own memory. We change the addresses here, the placeholder addresses, to the correct addresses, which we can only find this one during runtime, and this one as well. And then this is where we're storing the original instruction pointer. So at this stage, this would be pointing to the thread's own code. So it would be the original instruction pointer. And so we're storing that in the shellcode, so that when the thread runs our shellcode, it points back to the original thread's code. Okay. And then we're putting the DLL path into our buffer here, into the memory, and then we're going to copy that memory into the target process. We point the thread to our shellcode, and then we resume the thread, and it executes the instruction which it's pointing to, which would be our shellcode. It executes that, and then we close all the handles, free the memory, and we say that we successfully injected. Okay, so I made an error in the code here. When we're allocating the memory here, I forgot to put the correct flag, so I just put read write, but we need to have execute permissions as well, so we can execute the shellcode. So you need to put page execute and read write as well, and that should work. So I'll build that, and I'm going to test it on CSGO. I'm using the DLL that I made in the last video. All it does is just, once it's injected, it just shows a message box. That's it. If you do want to see how I coded it, you can watch the last video. Yeah. Okay, so CSGO is open. I'm going to run the injector here. It says successfully injected. I click into CSGO, see here, success, hello from inside the process. So you see in the background, CSGO is frozen. Like, it's not saying that it's not responding, it's just frozen, it's not going to crash or anything. That's because our DLL is running inside CSGO's thread, okay? So this is how you know if the injection is using thread hijacking, or if it's creating its own thread. So if it was using the technique that I showed in the last video, where it creates a new thread, CSGO wouldn't be frozen right now. It would just have the message box, and CSGO would still be running. But since we're executing this code from within CSGO's thread, basically CSGO is waiting for our code to finish executing, and then it'll start executing its own code. So if you're using thread hijacking, I would recommend not using functions like message box because it freezes the game, or using sleeps, because if you sleep for like 10 seconds or whatever, the game's gonna freeze for 10 seconds, right? So yeah, so once I click OK and get rid of the message box, CSGO continues executing, right? It doesn't crash, it's just frozen because basically it's like our code's running with CSGO's code. Okay. So that was thread hijacking. Thank you so much for watching. All the source code and the files I use are going to be on my Patreon. Link in description. $5 and you can get access to all my source code from all my videos and all the files that I use. If you would like to see manual mapping, which I'm thinking of doing, I'm not too sure, let me know in the comments below if you want to see manual mapping or a different type of injection technique. I'll try to show it to you guys. If you have any other video ideas, let me know down below. I am working on the internal hack tutorial. I've got this project, I've almost finished the project. It's using a universal directx hook. So basically if you inject it into any like DirectX 9 game like CSGO or like Borderlands 2 or something, you just inject it into the game and the menu should be rendering, everything should be working, so it pretty much works like in any game. I have wall hacks working. I've also got aimbot working, but it's the code's pretty bad. I need to like improve the code, so if I do fix the code and simplify it, I'll show it to you guys. But basically right now I've got the menu working. It works in any DirectX 9 game. You just inject it, the menu shows up. And I've got wall hacks working like cams. I'll try to do box ESP. But yeah, so that'll be coming soon. Thank you so much for watching and I'll see you in the next video.